Alright, so this is my second video on graphing a sine function. If you missed video number 1, check it out on my YouTube page, Mr. Yasuda's math videos. And I'd watch that one first because I'm going to talk about the basics of a sine function there. But just as a quick refresher, remember that a sine function has amplitude, and the amplitude is how high the graph goes and how low the graph goes from the middle line, and it also has a period of 2 pi, and I'll make a video on period changes. It also has a domain, right, of all real numbers, so from negative infinity to infinity on the x-axis. Remember that our x-axis is representing the radians or the angle measures, right? And then your y-axis is representing your just ratios or the values you're getting after you plug it in. So we should always label our x-axis. So we said if it's going to go from 0 to 2 pi, you'll have 5 points total in a period. And I made my notches go by 2 here. So this will be 1, this will be 2, and then this will be pi halves, pi, 3 pi halves, and 2 pi. And you're going to just plot the sine graph like we did before. We said sine always starts at the middle, so sine of 0 is 0, and then the sine of pi halves is 1. The sine of pi halves is 1. The sine of pi is 0. The sine of 3 pi halves is negative 1. And the sine of 2 pi is 0, and this is what 1 period of a sine graph looks like. And then you can extend the graph in the sense that you can keep going, you can make more notches, right? And you can keep adding to this periodic function by doing more periods, by just adding the periods. So from 0 to negative 2 pi you could go, and then you could keep going and keep graphing because the pattern will be the same. So what does that mean? That means that really, in essence, we're going to talk about transformations. We talked about a vertical stretch or a vertical shrink is really what's happening with the amplitude. And now in this video, I'm going to talk about vertical shifts. And so the vertical shift will take place when you're looking at the graphing form of sine. The vertical shift will take place when you have a value here in D. That's your vertical shift. And it's directly correlated to whatever's being added or subtracted there as that constant. If it's a 2, then it's going to shift up to the whole graph, or it'll shift down to. Once again, just real quick, covers our amplitude, and that is all we're going to see in this video. If you need to see period changes or horizontal shifts, check out video 3 or 4 on graphing sine functions. Okay? Alright, so let's get to it. Graph the function 2 plus 3 sine of x. So if you watch my first video, you know that I break everything down so that I can kind of see what I need to do. So that's the first thing I'm going to do. So I'm going to ask for the amplitude. I'm going to ask for the period. And I'll ask for the vertical shift. And those are going to be things that I want to know so that it can help me make a nice graph. So the amplitude is the coefficient, so that'd be 3. The period is still 2 pi because there's nothing on the inside of the sine function. And the vertical shift is going to be up to, and you should probably describe it. You shouldn't just write 2, or if it was down 2, you shouldn't just put like negative 2 or minus 2. You should put up 2 or down 2. Then what we're actually going to do now is we're going to draw in, okay, I would encourage you to draw in the middle line. Okay, so the midline is what we're going to draw in. How do I know what the midline is? It's just the vertical shift. So we've gone up 2. So here we have it, right? I'm just going to go by 1s here since we have an amplitude of 3, and if I go by 2s, I might end up off there. But here is our midline that I would have you draw in right now. And so that's going to be the middle of our graph. So the middle of our sine function, in the sense that the sine function should be equally above that line and equally below it. Next, we're going to draw on our x-axis, or we're going to define our x-axis. And since it goes from 0 to 2 pi, that means that we'll go from here 0 to 2 pi, and we need to label our x values. So pi halves, pi, and 3 pi halves. Okay, and if you want, you can do your second period as well. I always ask my students to draw 2 periods, and so then this period would end at negative 2 pi, so that'd be negative 3 pi halves, negative pi, and negative pi halves. Okay, and so if our amplitude's 3, then that means that's how high we're going to go up. But first, remember, sine always starts at the middle. So it's not going to start at 0, 0 anymore. It's going to start at 0, 2 in this problem. And then we're going to go up the amplitude. So we'll go up 3. Then we'll go down the amplitude. So down 3. And then we'll go down 3 again. And then up 3. And here is what one period of this sine graph would look like. And we can make our other one by continuing. Nope. That was a joke. Continuing the pattern. And there we have it. Once again, the domain is all real numbers, but the range is going to go from negative 1 to 1, 2, 3, 4, 5. And so negative 1 to 5. So that would be it. Alright. I don't know where my graph went. Where'd it go? There it is. Oh, it disappeared. Anyway, there is our graph. Okay. So let's move on to another one. Let's kind of put some other reflections and things like that in there just for practice. If you want to pause the video, you can. I'd encourage it. You could pause the video and then graph it and see if you come away with the same graph as me, or you can follow along. So once again, let's break it down. We've got our amplitude that we're going to want to find. We want our period. We want our vertical shift. Also, I'm going to throw in, let's go with our domain, which we already should know if you've been paying attention in class. That would be all real numbers. And then we want to know our range. And you could probably figure out your range without having to graph it if you think about it a little bit. Okay, so what's our amplitude? Our amplitude is going to be 2, but we're going to remind ourselves that we want to do a reflection because it's negative. The period hasn't changed, that's 2 pi. Our vertical shift is down 4. Okay, and we have the domain of all real numbers. So here we go. Let's make our x-axis. Let's go by 2's again. We know it's going to end at 2 pi. We're going to make our y-axis go by 1's though. Okay. And we're going from, let's make it a little darker, negative 2 pi. That'll be negative pi. This will be pi. And that will be 2 pi. In between is 3 pi halves. That means this one's negative 3 pi halves, negative pi halves, and pi halves. Okay, we're going to draw on our midline. Our midline is represented by the vertical shift, so it's gone down 4. So I'm going to draw in this dotted line, because it's not really a part of the graph, but my graph should go equally above it and equally below it. And then we remember that we're going to start at the middle. So here we go, start at the middle, but notice we have a reflection taking place, so that means I don't want to go up the amplitude first with a sine graph, I'd rather go down the amplitude. So down 2, point, then up, and then down. And that is our sine curve. Okay, and you can keep the pattern going to graph your second period. And that way we can also see our range if we want to do that. The lowest it goes seems to be -6, so we'll go bracket -6, and the highest it goes is -2. So that will be our range. All right, so here's our video on vertical shifts. Hope you enjoyed it. Have a great day.